Labguy here. I'd like to start this video with all apologies to Wes. This is a watch Labguy Work video. I am going to do some rework on this board and complete the new deflection amplifiers, and this video will consist of watching me cutting wires and rewiring the circuits and so on. It's a physical construction video. Probably not the best video, but it does give you an inside look at my construction techniques for all of the people who are joining us recently who have not watched my earlier videos on how I build things. Once in a while I go back and recap how I do things, and that's what this video is. And it's bringing the board up to completion so that we can put the camera back together and begin testing again. Remember, we were working with two issues. One is real and one is possibly a problem. That was the deflection of the image area in the tube may not have been maximized. The amplifiers I had built previously had an upper current limit, and so I don't know that, and since I couldn't see, when you expand the scan in a camera tube, it will reach a point where it starts to hit the sides of the tube and you'll see the curvature. Well, I couldn't get to that point with the scanning circuit I had, so I've constructed two new scanning amplifiers that are capable of much more current, and we'll see if we can drive the deflection coils out to the edges of the tube, because you want to scan as much of the photo surface as possible to get the highest resolution. The pictures with only 32 scan lines, you want every single bit of detail that you can get, because these are not brilliantly sharp images to start with. And so that was one issue. The other was the back focus of the lens. Somebody pointed out to me that I may have had a lens called a CS instead of a C mount. The C mount is a standard TV camera mount lens, and CS is for more modern cameras, which are much shallower cameras, and so its focal plane is closer to the lens. So I've changed the lens on the camera now, and we'll see if that helps. That'll be in the next video. I can only fix one problem at a time, so I'm fixing the deflection circuitry first. So in this video, watch me solder parts and wires. Enjoy, and I'll see you at the end of that. Soldering iron's heated up. Got a fresh schematic printed out. I've been rebuilding the deflection circuits, but they did get a bit busy and I got distracted by other tasks of life. So essentially on the schematic, all of the output side to the right of the op amp is wired up. Now I have to rebuild the front end slightly to bring it all up to speed, and that's what I'll be working on. So there we go. And sure we don't bang into the photo lights or anything else. So we've got the 6 potentiometers. The centering control needs to be rewired. I believe that the size controls, the size control needs to be rewired. The current controls are okay. The ramp current adjusts, so those are okay. So that would be that these two pots and these two pots need to be rewired, and I think I'll start simply by stripping away all of the wiring that's on them. Okay, the size pots are grounded. The current pots I don't have to touch, and the centering pot needs to be completely rebuilt. So the 2 center pots need to be rewired. So I'm going to remove all these dangling wires, just because. All right. We've got a problem. The board is wobbling on the transistor tops. You can't see. The 4 transistors here are taller than my standoffs. So I have to stop for a moment and extend the standoffs. Fortunately, I keep all my standoffs numbered for just such an occasion.
Fortunately, I keep my feathers numbered for just such an emergency.
I need 4 more. I wonder if these shorties will do the job. Hard to say. Let's see. Well, then it put the thing 3 feet off the table. Or is it 4 feet? Because it has 4 feet. Huh. Exactly correct. Okay. Alrighty. So I've extended the legs. I put these legs on so that when you flip the board over, you don't beat up the wiring and you don't beat up the parts. There we go. That's good to go. Turn it back around the way it's supposed to be. And let's see. No, it's this way. So the size pot, which is the first one, needs to have literally nothing done to it at this point. Okay, the centering pots yes, the centering pots need to have the ground removed from one side. And they share a ground with the size pots, which they don't anymore in the new design. The centering pot swings both plus and minus voltage. One more solder cleaning on these leads. Okay. That's okay. And lift this one up without tearing the pad off the circuit board. So we'll melt the solder while we lift. Here we go. And we snip him off. Snip him off. 5K and 5K. So let's grab the meter and verify that we have a 5K already installed. here. Well, that's interesting. Oh. What the heck? Oh. That's completely wrong. Alrighty. So those current resistors. Oh. Okay. That's a 5K, and this is a 10K. Alrighty. That's incorrect. Well, no wonder I couldn't adjust the current. This thing is built incorrectly to start with. Oh, golly. Hold on. There's something funny going on. We're miswired. Okay. So this wire is wrong, and this wire is wrong. Alright, that's better. And that's good there. I need to get some resistors. Two 4.99K. There we go. Put them right here. There. These are not very big resistors, are they? I doubt if you guys can see them. Okay. Tag the other end down. Okay. Very good. I have a burnt wire I want to replace. It's not that it wouldn't work, it just doesn't look good. Okay. Yes, from there to there. Since we're here, we'll clean up any bad work. Okay. For those of you who have followed the channel for a while, you know that I like to use surface mount resistors and capacitors. because they fit between the pads on this circuit board perfectly. That's a size 0603, which means it's 60 mils long and 30 mils wide, which works perfectly to fit between 100 mil spaced solder pads. And makes the top layout of the board very clean because you don't have all of the leaded resistors. There are a few on here simply because of their power ratings. These are 1/4 watt resistors here, for instance, and I needed to rate them at 1/2 watt, and I needed 1.5 ohms, and I only had 3 ohm resistors, so I paralleled a pair of 1/4 watt 3 ohm resistors in 4 places. Okay, so next we need orange wire. Alright, orange wire. Orange, as some people say. Okay, and that's going to go there. Turn it around because it just makes it come out better. There we go. Orange color code on my systems means plus 12 volts. Next will be the minus 12 volt wiring to the centering controls as they swing plus and minus about 6 volts, so that we can take the scanning of the tube and move it left and right as necessary to center it on the imaging area of the tube. Okay, now this will come up this side. Turn it around. The purple wire here, the violet, will be tapped off here and brought up to the resistor and then looped over to the other resistor for the two centering controls. So maybe I want to go like this. That's correct. Okay. And I probably want to go underneath. Thus, I'm going to do this. Generally, when I do power wiring, power supply leads, I solder those all in first before I do the signals, because signal wires are the most likely to get reworked and moved around, and so you want them to be at the top of this mat. You see how when you put a lot of wires you generate a mat, and you want the ones that are going to most likely change to be on the very outside layer. So sometimes in rework I have to go back in and slide some wires underneath. Like this, picking up to the minus 12 volts. Oh, here we go. Alright, that seems okay. And, well, that's almost backwards. Almost. Alright. Do another trick then. Since we're here like this. Here. I don't have to cut this one there. Ouch, that's hot. And there we go. And it's connected. So the centering controls now are a 5K pot, I mean a 5K fixed resistor, a 5K pot, and a 5K fixed resistor in series with one outside tap hooked to plus 12, the other outside tap connected to minus 12, and the wiper at the center of the two voltages swinging plus or minus approximately 6 volts, plus and minus 6 volts. Done with the purple wire, or violet wire, or as I like to call it, violent wire. It's the most dangerous color because it's so closely resembles violent. Okay, so those are hooked up. Those now connect where? Ah, yes. Interesting. Okay, looking at our op amps. Okay, we need capacitors. 1 microfarad capacitors. Fortunately, I keep all my capacitors numbered for just such an occasion. 1 microfarads, I said. These are 10s. These are 0.1s, 10s, 0.1s. Come on, where's my 1s? 0.1s. Ooh, don't make me angry. Here we go. A 1 microfarad. So we need 4 of them. It says we need some 100K resistors as well. Okay. They come on this tape and reel. You just pull off the tape and get as many as you like. I get a spare one here. We'll pull out 5. Then I like to trim this off so that it doesn't have too long of a tail hanging on it to annoy me in the future. Into the trash. There we go. Alright, so now, okay, I need a 100K resistors. I show this every time, but I'll show it again. I buy these resistor kits. They contain, I don't know how many in each box. It's a total of 510 values of resistors. they're all 1%. So when I design and I need a pretty accurate value, I have it at my fingertips. So, 2 100K resistors. I only have 2 left in the box. It's all right if I run out of 100K, because 99.7 is the lower value and 102 is the next value. So yeah, it's not an issue. That's for this application is perfectly close enough, but I only need 2 and I have them, so we're good to go. Now let me look at my construction here to see how I'm going to proceed. Now, where to put the components? Okay, well, one capacitor comes off of the size pot. One capacitor comes off of ground. And of course I've got that purple wire right in the way. Oh, isn't that typical? Okay, we can unhook that and get it out of the way. So technically I can put both capacitors at the size pot like it's drawn on the schematic. And then the centering pot hooks to one of them. Yeah. Oh, the irony. I need to remove the purple wire I just put on, but I think I can just keep it and reuse it. There we go. Didn't scorch it too bad. Pull that out of our way. Alrighty. So, yes. Alright, that'll work. I have to move 2 of the 5K pots, 5K fixed resistors, because I need that location for the 100K resistor. No problemo. And that means that the purple wire won't reach. Okay. It might still work. Alright, let's see this purple wire. What if works? Perfect. All right. Good. Well, that's ideal. Wow. All right. Alrighty then. Turn around again. And the capacitors go in next. There and there. That's gorgeous. Here. That. This type of construction results in having to cut a minimum number of wires, actually, because when you're building this stuff, cutting and stripping wire, cutting it to the proper length and stripping it, can be some of the most time-consuming part. Move the resistors here. Spare capacitor. All right. Now the resistor, the 100K resistor is going in. The 4 1 microfarad capacitors are installed. 100K is right there. And the other one. Dopley, what have I done? Oh, there it is. Perfection. Oh, that's very nice. Now all I have to do is run a wire from each one of those to the op amp, one to pin 3 and one to pin 5. And the entire deflection circuit is finished. Wow. For those who haven't been following the channel, I buy these little spools of wire made by Page. They're expensive. When you buy 10 of them, it's going to cost you $150. I buy all 10 colors. And then I cut this diagonal notch into the side of it to hook the wire so that the thing doesn't unspool. All right. Okay. Let's see. We're going to go from there to there. Okay, we hold our wire and run it to here. Put a kink. I measure the length of the insulation and put a kink, and that's where I strip the wire. Let's cut it. And pull, and then you solder the end first, Slide the insulation all the way down with your tweezers, and now it's exactly the right length to where it needs to go. There. All right. Okay. So we'll do it again one more time. Strip that off. We're going from here to here. Now, unless I'm mistaken, the wiring is complete. We'll get some micro photographs for you. And put into the video. And in the next video, we'll go into the troubleshooting of the scanning circuits again, testing the camera. Well, I hope you enjoyed watching me work. If you like watching people work, you might check out a channel called Watch Wes Work, W-E-S. He repairs cars and trucks. Work is fascinating, isn't it? I know I can watch it all day. So until next time, this is Labguy, out.
Fortunately, I keep my feathers numbered for just such an emergency.